Hello and welcome to Water Quality. In this video I'm going to show an example of mercury complexation with chloride, and I'll demonstrate the two different ways to write out complexation reactions. Okay, so the first way I can write out reactions is stepwise, and the second way is overall. So we're going to derive the overall equations based on the stepwise reactions. So here are the stepwise reactions, and I'm going to label these 1, 2, 3, 4. And in each reaction, mercury is reacting with a single ligand, or chloride, and forming a complex. So free mercury reacts with a chloride and forms the first complex. That first complex reacts with another chloride and forms a subsequent complex, HgCl2, and so on. And the equilibrium constants that describe these reactions are K values with a subscript kind of denoting which complex it describes. And these can also be referred to as stability constants. Okay, so using these reactions and constants, we're going to develop the overall reactions below. Okay, so we start with the first reaction, the same reaction that we used up above, so there's no change here. The first overall reaction is the same as the first stepwise reaction. So mercury, or Hg2 plus, is reacting with a single chloride and forming an HgCl plus complex. But now, instead of calling it a K, we're going to give it the designation of beta. And this one is beta 1, and so on. Okay, so I'm going to write that our beta 1 is equal to K1. It's the same as up above. And now, in my next step, I am going to take this reaction and add it to the second reaction, which is HgCl plus chloride, and that goes to HgCl2, no charge. So I'm going to add these together, and when I do, the HgCl plus is on both sides of the reaction, so those will cancel out, and I end up with Hg2 plus 2 chlorides forms HgCl2 not. And this corresponds with our beta 2. So the 2 represents the number of ligands reacting with the metal. So here 2 chlorides are reacting with the mercury ion. Now, hopefully you remember, but when you add two chemical reactions, what you do to find the overall constant, equilibrium constant, is to multiply the K values from those reactions. So beta 2 is going to be the product of K1 and K2. So I put those together and I get 10 to the 14.05. The next step is to take the third reaction and add it to this one. So I have HgCl2 not plus a chloride forms HgCl3 minus. This is the third reaction. And again, HgCl2 is on both sides of the reaction, so that's going to cancel out, and I'm left with free mercury ion plus 3 chlorides forms HgCl3 minus. And the beta associated with that is going to be the product of K1, K2, and K3, and this gives me 10 to the 16.05. And that's our beta 3. And finally, going to add the fourth reaction, which is HgCl3 minus plus Cl minus forms HgCl4 2-. And I add those together, I get mercury free ion plus 4 chlorides forms mercury chloride, or HgCl4 2-. And then the beta 4 value is K1 times K2 times K3 times K4, which is 10 to the 16.75. And there you have it. We've looked at mercury complexation with chloride from both a stepwise and overall reaction standpoint.